All right, Brandon Clayton here, the Algebra Guy. Today's lesson, as you see on your screen, graphing solution sets of systems for linear inequalities. So up to this point, we've graphed solutions for equations where you have 1 point. Well, how do you do it for inequality where you shade in a whole region? So what does that look like? So let's jump to it. 3H is the T. Graph the solution set of systems of two linear inequalities and two variables on the coordinate plane. Here are the skills that we're going to accomplish today. Determining whether an order pair is a solution, solve a system of linear equalities by graphing, and solve applications. And we're going to bring out our calculator for that one as well. So let's jump to it. Two or more linear inequalities grouped together form a system of linear inequalities. A system of linear inequalities looks like a system of equations, but it has inequalities instead of equations. So it looks like this. So notice it has a greater than, equal to, or less than sign. So now it's just like the one before, but we now have these inequalities. Solutions of a system of linear inequalities are the values of the variables that make all the inequalities true. In other words, we're going to shade in a region and not just a point, and where both inequalities are going to cross on the graph. So we'll look at that here in a second. Let's first start by determining whether this order pair is a solution to this system. So as before, we can just plug in these points to see if it's true for both. So I'm going to start with -2, 4, and plugging in -2 for my x, and for my y, a 4 is greater than or equal to 10. So if you missed that, all I did was take this x and y and plug in these two. So let's see if this actually is true. -2 plus 16 is greater than equal to 10. -2 plus 16 is a 14, greater than equal to 10. Now we just ask ourselves, is that true? And this is true. But we're not done, because it's a system we're dealing with, so we need to make sure both equations can be represented as true. So now I got to put -2 and 4 into the second equation. So 3 times -2 minus 2 times 4 is less than 12. So is that true? So this gives me -6. -8 is less than 12. -6 minus 8 is a -14. And that's less than 12. Is that less than 12? Is -14 less than 12? It sure is. So this is one of the solutions for this inequality. Notice I didn't say it's the solution, because it could be many solutions for this one, since we're dealing with greater than or less than. So it could be everything within a certain region. But we just want to start with the points. Let's do the same thing with this one here. 3, 1. I could plug in a 3 plus 4 times 1 is greater than or equal to 10. Let's see if this is true. 3 plus 4 is greater than or equal to 10. And 7 is greater than or equal to 10. And we know that 7 is not greater than or equal to 10. So this is not going to be true. I don't even have to check for the other one, because it won't matter. If one of them is not true, then there's no solution there. They both have to be true. All right, let's move on to our next problem. So let's do inequalities by graphing. How could I find the solutions by graphing? The solution to a system of two linear inequalities in a region that contains the solutions to both inequalities is found by finding where they overlap. So let's first graph each inequality. So graphing inequalities are going to be similar to graphing equations, as we've discussed. First, let's draw the boundary line. Y is equal to 2x minus 1, because this is equal to on this equation. So we're going to start with our y-intercept at -1, and we're going to apply the slope of 2 up 2 over 1, 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 up 2 over 1. So same thing I can do is go down 2 over 1. So there we go. Now I didn't have to get all the points, but hey, I was on a roll, feeling good. So I'm going to draw a straight solid line here. Why? Because this is equal to. Now it's in slope-intercept form, so I can see that it's greater than or equal to, which means I'm going to shade everything above that line. But I'm going to wait for that here just a second before I do this other one instead first. So y is less than x plus 1. So here's my 1, and my slope is going to be 1 here. So up 1 over 1, up 1 over 1, here, 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 here. So there are all my points here, and I could probably stop there and go ahead and make my line. So that's what I'm going to do. So there's my line. Let's see if that's pretty accurate. Yeah, that's pretty good right there. All right, so now we're going to think about where these two graphs are crossing. So for the first one, let's go back to the blue. Everything greater than 2x minus 1. So that means everything above this line is shaded. So let me go ahead and lightly shade. If I can get a lightly shade. So if I'm shading up here, try not to mess up my yellow line too much, but everything above that line. I know it's not pretty, but you get the idea. So all these are possible solutions. Now we look at the y, and it's everything less than, so everything below this line. So if I had to shade in everything below the y, it's going to be everything here. All this stuff right below that yellow line. All this area here. So yeah, it looks like a hot mess, doesn't it? All right, so what I'm curious about is where they cross. What are these two shaded regions cross? So if you can look through all the mess we just made, they cross right here in this space here. So I'm gonna see if I can make this even more dark. So all this space right in between. So above the blue line, but below the yellow line is where those spaces are crossing. So this right here, all the points in that region will be considered solutions to this system of inequalities. So any point that you take, -2, -3, -4, -4, -4, -5, any of these points within the shaded region where they cross are going to be considered solutions. So let me review what we just did. We graphed both. We shaded above because this one said greater than or equal to. We shaded below because, you know what, I just realized I shouldn't have done, this should have been a dotted line. So sorry about that. I should have left this a dotted line because everything on that dotted line will not be equal to. Because this is no equal to sign. So please dismiss that. But everything in between here is our shaded region, but we're going to have a dotted line here. So this should be, it's kind of tough to write now, but this should be a dotted line for that y is less than x plus 1. All right, let's go to our next problem. Solve this system by graphing. Let's put them both in slope-intercept form to make it easier to graph. So I'm going to put this one in slope-intercept form. X minus y is greater than 3. So subtract x plus 3. And we're going to divide or multiply. Let's just say with multiply. It's easier to multiply by -1 to get rid of that -1 here. So that makes this a positive. Now that changes the direction of this sign. So now I have a positive x minus 3. So this is the same thing as y is less than x minus 3. So if I graph that one, I have a y-intercept at -3. This time I better keep this line dotted. I'm going to try to remember that this time. So I have a slope of 1 up 1 over 1. So we're going to try to remember. Don't let me forget not to shade that line in. Yell at me if I do. All right, so we're going to keep it just like that. We're not going to make that a solid line because it's not equal to. And we have another here. So this is our blue. We're going to change this to yellow. We have a y-intercept at 4 and -1/5. So we go down 1, 1, 2, 3, 4, 5. Down 1, 1, 2, 3, 4, 5. And we can go up 1, 1, 2, 3, 4, 5. Now I'm so tempted to connect those dots, but we need to make sure it's clear that we can't include all the points on that line. So I could put dashes here to make this more apparent that there's a line there. But I don't want it 1, 2, 3, 1, 2, 3, 4, 5. So I don't want to connect them though, because that's going to suggest that they're equal. All right, so now if we shade it in, let's start with this one here. Let's start with the blue. Y is less than x minus 3. So less than x minus 3 is everything below. So let's pretend this time that I'm not going to shade it in to make all that craziness, but let's pretend that we shaded everything in here below the blue. And we want everything here that's below the yellow. So everything below the yellow is shaded, everything below the blue is shaded. Where are they going to cross? Well, they're going to cross right in this area here. So all this area here, they're going to cross. Because this is the area that's below the yellow line and below the blue line. So they're crossing in this area. So any solution here, we're going to call a part of the solution set for this inequality. So all the solutions here. So let's double check that. Everything less than y equals x minus 3. So this is the line. So yes, everything below. So we could have shaded that one, but we need to include this one as well. Everything below the yellow line. So that part is not below the yellow line, so we include below the yellow line. So this area makes both of these true for that system. Notice it's not a point, but a region where they're both being where they're both overlapping. So any point you take there will be a solution to that solution set, or a solution in that solution set. All right, the point of intersection of two lines is not included as both boundary lines where you have a dashed line. This is what we talked about before. So if they cross, if two dotted lines cross, you can't include that point because the dotted line itself means not equal to. So we can't say, oh, they're equal to at that point. Let's graph this one and see what this one looks like. I'm going to change this one to slope-intercept form. So 2y is less than, we're subtracting x on both sides, plus 5 divided by 2. Y is equal to, y is less than negative 1/2 x and 5 over 2. Alright, sorry, divide by a negative 2. Let me just go back because I don't want to mess that up, because that's a big part. So we're dividing, so we subtracted our x and we're going to get this, we have this negative 2y and we need to divide by negative 2 on both sides. And that leaves us with y equals, now I change the direction of the sign to greater than, and this is a 1/2 x, because that's a 1 over negative 1 over negative 2 is 1/2, and 5 over negative 2 is negative 5 over 2. All right, now I know this equation is the same thing as y is greater than 1/2 x minus 5/2. What's 5/2 so I can graph it on the decimal? That's just negative 2.5, so that's about right there. It's going to be a little bit tougher graphing this as a decimal, but we can do it. Up 1 over 2, 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 and down 1 to the left 2, down 1 to the left 2, 1, 2. So down 1 to the left 2. So we get the idea. All right, so those are my dots. I don't want to make that straight line. Why? I don't want to draw that line because they're not equal to. So I need to keep it dotted to remind myself and communicate to anyone who's checking this that all the points on that line are not solutions to this equation, to this inequality. So the other we have is y is greater than negative 4. So y is equal to negative 4 is right here. But we can't draw a solid line. Why? Because it's not equal to. All the points on that line cannot be considered for making this inequality true. So the point where they cross right here, this is not going to be a solution as well, because none of these lines in a sense exist. We can only say they're greater than or less than that line. So what's the solution here? So we have the y is greater than that line, so everything above. So imagine all this above the yellow line is shaded. So all this stuff up here above the yellow line is shaded. For the blue line, so let's underline this blue so we know we're talking about this, the blue one. We want everything greater than, so everything above the blue line and everything above the yellow line. So what area are we talking about they both have in common? So everything above the yellow line, so this is below the yellow line, so we don't want anything here. But above the yellow line would be everything, above the yellow and blue would be right here. Uh-oh, no, I don't want to make that solid. All this space right here. All right. Yeah, that's a good way to do it. I could just put a big box around it. So all this space above the yellow line, because it's greater than, and greater than the blue line. See, this is greater than the blue line, but it's not greater than the yellow. It has to meet both. So if I were to shade all that in, which I'm not going to do a perfect job of now, but enough to give you the idea that all the solutions in this space, all these are solutions that are in this space. So if the test asks us, is let's say 0, 0 a solution here, we can say yeah, because it's right there. It's in that space. It's in this shaded region. All right, let's solve this one. Again, we're going to put both in. We don't have to. We can actually use the intercepts to find this one. I like to use slope intercept because it's easy to see which side we need to shade. So I'm going to go ahead and put this in slope intercept form for that purpose. 3y is greater than or equal to 12. Subtract 4x. That leaves me with 3y is greater than or equal to negative 4x plus 12 divided by 3. And that leaves me y is greater than or equal to negative 4/3 x plus 4. So now I know that's the same thing. This one's already done for me. So let me go ahead and graph this one. We're going to start at 4. And it looks like it's negative. So we're going down 4 to the right 3. Down 4 to the right 3. 1, 2, 3. Down 4. 1, 2, 3. 4. 1, 2, 3. And I like to see that they're straight. That means I'm doing it right. 1, 2, 3, 4. 1, 2, 3. All right, now I can finally put a line here, okay? Because I've been wanting to put this line so badly. Now they're equal to, so I'm going to be very happy to draw my line. Yay! I can do that guilt-free. All right, there we go. I'm gonna finish it out here just to show you what it looks like. All right, so let's do the other one now in our different color. We're gonna do this one in yellow. So this one in yellow, we're gonna start out at 1. And we're gonna go down 4 to the right 3 as well. Down 4, it looks like the same slope. So what is that telling me? Actually, just when I saw that, look, same slope. So what does that tell us? They're parallel. They're gonna have different y-intercepts. Obviously, this one has 1, this one has a 4. The curious thing is, will we have, well, let's just finish it graphing and see what happens. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And to no surprise of us, 1, 2, 3, 4, 1, 2, 3, it's not crossing. 1, 2, 3, 4, 1, 2, 3. So I'm going to draw my line to connect all these. There we go. That looks pretty straight. Now, I'm curious as we shade in what it's going to look like, right? So let's start with the blue one. Y is greater than that line. So we want everything above that line. And the yellow is Y is everything less than that line. So let's shade that in. Everything less than this line is here. So all this region here, I'll just go ahead and kind of shade that in. Oh, that's beautiful shading right there. All right. So for our blue line, we want everything that's greater than or equal to. So everything that's greater than. And now we're looking for where do these two overlap? What do these two cross? And you probably already knew that before, but I want to go ahead and give you this visual. Look at that. Look at that beauty. They don't cross at all. So what are you going to say? We're going to say no solution. There are no solutions. There is no point where these two are ever going to be equal. If you put a 1 here for this x, so let's say 1 here for this x, you're going to get a different answer for this y. I mean, this one in yellow, and you're going to get a different answer in this blue. They're not going to cross. They're never going to share the same answer for the same points. So that's our answer for that one. All right, let's do this one. I can tell what this was going to look like. We have this first one. Let's go ahead and graph that. I'm going to do it in a different order this time. So I'm going to graph this one at -4 and 1/2, up 1 over 2, up 1 over 2. Now it's not equal, so I better not remember or better not forget to keep these dots here and not shade them in because it's not equal. 1 down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. All right, there we go. I'm not going to do it. I'm tempted to connect those dots, but I better not because it's not equal. So I can put these little dashes if I want to, but do not connect them. All right, so let's go ahead and put this in slope-intercept form so I can see how to shade it more easily. I'm going to subtract x on both sides. Negative 2y is less than negative x minus 4. Divide by negative 2. Dividing by a negative makes this sign change the other way. Negative 1 divided by negative 2 is a positive 1/2 x. Negative 4 divided by negative 2 is a plus 2. So let's graph this one. I should have changed the color, but this is I'm gonna use my yellow for this one. So starting at 2, up 1 over 2. We got the same slope again. So let's see how that's going to affect us on this one. So as you can see, they're parallel lines because they have the same slope, but depending on how we shade them will make the greatest difference. So y is greater than, so that means everything up here needs to be shaded. All right, so actually let me lightly shade all that. So I'm going to shade all this stuff up here. And then for the other, we have, this is my blue one. It says y is greater than as well. So everything from here up. All right. So where do they cross? They don't cross here, obviously. There's no yellow here. They only cross from here up. So all the solutions here are what I'm going to take. So everything up here where they're crossing is what I need there. So any solution there will give me my answer. All right, let's finish off with a word problem. Omar needs to eat at least 800 calories before going to his team practice. All he wants is hamburgers and cookies. And he doesn't want to spend more than $5. My goodness, where are you going to shop? At the hamburger restaurant near his college? Near his college? That's really going to be expensive. Each hamburger has 240 calories and costs $1.40. Each cookie has 160 calories and costs 50 cents. Write a system of inequalities to model this situation. So I'm going to actually take out my calculator for this one because I can see that it's going to be better with these numbers to graph it on the calculator. So let's do that. All right, here I got my calculator out. I'm going to get my graph ready because I bet we're going to put this in the graph. All right, so first thing I'm going to do is identify some variables for the hamburger and the cookies. I'm going to let the hamburger, let's write it. I'll write it here. I'm going to let the hamburger equal the number of hamburgers. I'm just going to hamburgers. I was going to abbreviate, but there we go. And the number, actually, you know what? I'm going to make this equal to X because I'm going to put in my calculator and it's not going to like H. So let's use X instead. And I'm going to use Y as my cookies, my number of cookies. All right, so let's write a system here. So what do we know? We know that he at least wants to eat 800 calories, which eating cookies and hamburgers is going to get you there pretty quickly. That's just a side note. But we need at least 800 calories. So we can have equal to or greater than. So it can be equal to 800 or greater than 800. So what do we know about the calories of a hamburger? So hamburger says hamburgers have 240 calories each. So each hamburger is 240 calories for each hamburger times every hamburger. Plus, what about the cookies? Well, there's 160 calories for every cookie. 160 calories for every cookie. And I just realized I'm writing H there, but I want to write X because I'm going to need that later, and Y for my cookies. So that's one inequality that we need. And the other is dealing with the money. He only has $5. He can spend no more than that. He can spend equal to $5. He can spend less than $5, but he can't spend more. So he needs to be less than or equal to that, $5. How much is a hamburger? So my hamburgers, represented by my X, are $1.40. $1.40. Plus my cookies are 50 cents. 50 cents per cookie. So these are the inequalities I'm using to graph this system. So let's graph this system and then we'll answer these two questions. Could he eat 3 hamburgers and 1 cookie? Now you can answer this pretty easily by just finding the cost of 3 hamburgers and a cookie and seeing if it's less than $5, less than or equal to $5, and if it matches the calories. So that's one way you can do if you have a word problem like this and you don't want to or don't remember how to do what I'm about to share with you. Just plug in these 2 points. That's really what they are. Just plug in these 2 points and see if it meets the criteria of having 800 calories or less and $5 or less, and you're done. You can say yes. Could he? Yes. Could he do this? Yes. And you can show your work by checking those points, putting those points into the equation that you're showing that you checked how much it costs. So anyhow, let's get to our graph. So I want to put this in my graph and show us how we can do this. All right, so make sure I got everything set up right. Yes. And I'm going to make an inequality. So I notice it's in standard form. I'm going to use relation. So I'm going to press delete on here and press relation. Yeah, because I don't want to try to solve for y and all that jazz. I just want to leave it this way. So 240x plus 160y is equal to 800. But it's not equal, is it? I meant to say it's greater than or equal to. So let me press Control equals and get that greater than, not just greater than, but greater than or equal to. There we go. Look at that, make sure that's good. Yep. Thank you. We're going to press enter and look at this beauty. It actually graphs it for us. What a time saver. All right, so now we're going to do the next equation. Press tab and 1.4x plus 0.5y, because that's the same thing, guys. 0.50 is the same thing as 0.5. I better write it because some people get mad at me if I don't put the 0 there. All right, so I'm going to put less than or equal to sign right there and press 5. So double checking to make sure that looks good. It does, and I'm going to do that. Look, you can see where they're crossing right here. Let me move this out the way. This region right here are all the possible points that you could have to meet this criteria. So let's see if he could eat 3 hamburgers and 1 cookie. So let's see if we can count it. 3 hamburgers and 1 cookie. And I need to zoom in a little bit here. So let me zoom in and see if that helps. So zoom in about right there. Oh, that makes it hard to see my numbers. So let me go back. All right, to see if this will work, I put some grid lines here, and I just went to, in case you want to know how to do that, view, and you can find the grid lines here. You can add that to there. But I went here and I'm looking for 0.31. So 1, 2, 3, up 1. You notice that point is right here. So I can see that that point is in this solution set. Also 2, 4, 2, 1, 2, 3, 4 is right there too, right inside of it, which is just enough. So both of these are acceptable. So yes, he could eat 3 hamburgers and a cookie, or 2 hamburgers and 4 cookies, and meet both of those criteria. Let's go back to my screen here. All right, normally at this point we'll work star problems associated with this TEAK. However, I didn't find any between 2013 and 17 over this. This recording's in 2019, which tells us it's really not. Now I could have missed 1 or 2, but it tells us it's not often tested. But often you need to know how to do this in class, but it just hasn't come up on the test. That's it, guys. Look, we've covered everything. Graphs a solution set of systems of 2 linear inequalities in 2 variables on a coordinate plane. Fantastic job. Now you know it's just where, not just where 1 point where they cross, but where those graphs regions are crossing. My name is Clayton, the Algebra Guy, and I will see you next lesson.